Alright, welcome to the second part in Chapter 1 Kinematics, where we're going to be using the knowledge we learned in the previous video to make our own physics engine in Unity. Now, that sounds like a big thing to do, right? Because a physics engine has so many parts, but we'll get through it over time as we work away at it. So, quick recap. In the last video, we learned about this magical equation which describes the position of an object at any time given some values. So this is the position, and you must know constant acceleration, or rather you must assume constant acceleration and know it as well. You need to know the initial speed, and you also need to know the initial position. Quick side note, in the last video I called these terms right here, I called them variables. They're not. They're constants. It's just that my mind at the time wasn't working, so I for some reason called them variables. No, they're constants, because if you think about it real quick, the position that you first launch a ball down from a 8-story building, for let's say, the position in this scenario of the ball, right, it doesn't change. This y naught is it stays the same. It's a constant, right? And then if you were to throw it down, you were really mad, right? It's your friend's favorite ball, and so you're throwing it down to the ground because you had a dispute with your friend. I don't know, but that first velocity, which is v naught, is also constant because you can't really go back in time and change it as time goes on. It's just something that was given to you at the beginning, and so it cannot be changed. So just real quick, these two are constants, they're not variables. Alright. Okay, so now let's actually get down to making the physics engine. Here I have an empty Unity project. It's a 3D project, so you can make one yourself if you want to. And I'm going to create a new C# script by right-clicking in the assets area. And I'm going to actually you know what, I'm going to call it physics engine. No, let's give it a more interesting name. That's too boring. Calling a physics engine? Nah. Let's call it WMP, standing for Wave Matter Physics. Yeah, that's so much cooler. Anyways, we're going to wait for it to load, and we're going to double click it to open it up. And let me just shift my screen a little so that you guys can see. Here we are. This is an empty script. This is our start function where we can set up a bunch of stuff. This is our update, which updates at like something like 60 frames per second or something like that. Whatever Unity does, updates at. And to start off with, I'm going to make 3 public variables, right? So I'm going to make public vector 3, and I'm going to call it accel, semicolon, standing for acceleration. Now, we'll talk about why this is a vector 3 later. We'll talk about vectors overall later, but the reason why it's public is because I need to be able to change this number from within Unity, and if I didn't have it as public and rather had it as private, it would only be able, I could only change it from within this code and not within Unity. So I need to have it public, and I'm going to copy this because I'm going to make 2 more public vectors. Right? And these are going to be my three knowns that we were talking about. My initial... I spelt that wrong. Initial underscore speed, actually. Speed, yeah. And then I also have my initial position, or pause, because I don't want to write out position. So, we have our three variables now, so we can start doing stuff with them. Let's save first. You always want to save. And to start with, let's set something up. We know that this script will be attached to a game object, right? And that game object has properties of its own. As a matter of fact, if I show you right here, if I were to make a 3D object cube, it has a whole bunch of properties. What we're interested in right now is the transform component. Here you can see that it has a rotation, it has scale, so I can make it really long. See? Or I can make it really tall. Yeah? Kind of fun. Now, what we want is the position. Does this word ring a bell to you? Position? Well, if it doesn't, let me just show you. By going here, we have initial position. So, using this, we can, because void start is only called once at the beginning of the game, we know that the transform.position, right, because the transform component, dot, which is identifying something under it, and then we can find the position. So we can say that the transform form dot position, if I can spell this right, position during void start is going to be equal to our initial position. And boom, we already have one variable set. We don't even have to change it. We can still change it if we want to, but Control S, we don't need to because the program does it for us. Now, that's one variable out of the way. The other two we have to edit ourselves within Unity itself. But let's get to actually making the equation. Right, so in order to figure out how we're going to make our equation within Unity, we need to figure out what x as a function of t, the first part, the very beginning of our equation, actually means in Unity terms. Well, if you think about it, transform.position in our start function is just the position at the beginning of the game, or beginning of the program, or whatever, right? And it's some set value, yeah? And this makes sense. Actually, it does make sense. I just have this written the wrong way because I was setting the wrong thing to the wrong thing. That doesn't make any sense English-wise, but those who know understand. Right? So, if a transform.position in our start function is the beginning, that must mean that our transform.position in our update function, which is constantly being called upon, it's constantly being updated, right, as time goes on, starting from the beginning of the game or program. So this is basically our x as a function of t, because it's our position at any given time within the update, right? So position, there we go. Don't mind these warning things, by the way. My parents are incredibly strict with how much time I get to spend on the screen, so they have this entire parental safety thing that they have set up where they can monitor the amount of time I spend on a screen and lock down my PC, stuff like that. Anyways, and I'm going to leave transformed up position hanging because I don't want to write out that huge equation because it is actually kind of big when I write it out in unity terms. I don't want to write out that equation here. I'm actually going to make a separate function, right? And we're going to call it public vector3, and I'm going to explain the vector3 bit just a second, and I'm going to call it get position. I'm going to set its parameters to float and time. Right? And there we go. So, the reason why I have a vector, and we're going to go more in depth on this later on, specifically in chapter 2, which has to deal with vectors, but the way a vector works is that with a normal number you have just one value. Well, with a vector 3, your any number that is a vector 3, so for example, if we were to take acceleration as a vector 3 is not one number, it's actually three numbers. You have the x component, the y component, and the z component. Again, don't worry about this too much for now, but basically we need to make a float because we have everything's done in floats in Unity, honestly. Floats help quite a lot. We're going to make a float, and because we're going to be operating on the y axis here, I'm just going to call it float y value. And then I'm going to set that to the huge equation that we have ready. Into time to the power of 2 over 2 plus initial speed. Gotta love how Visual Studios gives you all of these things. Oh, never mind. There we go. Into time plus initial position, tab. And there we go. That's the magical equation within C# and by extension Unity. So this looks all fine and dandy, but the thing is, this little bit here actually doesn't work out because in what's it, Unity, the operand to the power of, or the up arrow, actually doesn't mean to the power of. It means something completely different. So if you want to do times squared, you actually need to, or anything to the power of something else, you need to call upon the math machine that Unity has built in, which is kind of cool. And then you go do math.pow, which means mathf.pow. Mathf is calling on all of Unity's mathematical functions, and then pow just allows me to, square or cube something. Then I put in my parameters, time, and these are floats, by the way, which is why I have time written down as a float. Otherwise, this would not work out. And 2f. And now this should work. If I just add another end bracket here. Right? So, now we have the magical equation. And we have the to the power of thing figured out as well. mathf.pow. Now, we need to set it to the position. And you'll see why I said y value here very soon, because I'm going to make yet another vector 3, and I'm going to call it position, and this is the position. Always be careful with your spelling in coding, because if you name something like position, positon, and then later on want to call upon position, but you spell it right that time, well, guess what? The code doesn't know that you actually meant to spell it position, and it just assumes that, oh, the variable position does not exist. Please try again later. When in actuality, it's just a typo. So always be careful with your spelling. Caps lock, uncaps lock, like everything matters spelling wise in Unity. Anyways, back to the actual coding. We're going to make a new vector3 position because position is actually also a vector. I'll show you this in the Unity game engine later on in this video where I'll show you the x, y, z values. But vectors are calculated in floats again, or at least their components are. So I'm going to set the x value because it's done x, y, z. I'm going to set the x value to 0.0 f. I don't think I need the 0.0, but let's add it in, why not? I'm going to set the y value to the y value that we're calculating here, because remember, we're doing this on the y-axis just because it's cooler to visualize. And I'm going to set the z value to 0f as well. And basically what this is doing, oh, wait a moment. Just a new vector3. There we go. Semicolon. And basically what it's doing, this entire function, is doing is it's going to make a float called y value. It's gonna set it to acceleration into, the magical equation. It's gonna set it to the result of the magical equation as a float. Then it's going to make a new vector3 called position. It's going to set it equal to a vector3 where the x value, remember it's x, y, z, alphabetical order. The x value is going to be 0. The y value is going to be the result of the magical equation. And then the z value is going to be 0 because we're doing this on the y-axis in this specific scenario. And then we're going to do return position, which is basically going to going to return the value of position, because this is a function and every function needs to return a value in order to actually be used. Right? So, we're going to now go back to the void update. That was all like fine and dandy. We've done this. Hopefully I did a good job of explaining it, but now we need to actually apply this magical equation because we have the equation. It's being set to some value and we're returning the value. Now we have to do something with that value, right? So we're going to call upon the function getPosition, and we're going to set its parameters, which is time, right, to time dot. I don't know if Unity has it as capital T or small letter t. We'll find out, I guess. Let's do capital T. I feel like it's capital T. Fixed, unscaled time. And what this is doing is it's basically linking this thing, which is a property of Unity itself, to this piece of code, which is using a float time. So basically every time I see time in this little function, it's going to go, oh yeah, this, by the way, is linked to this here. And this here is defined by the game. And that's the only way that we can actually get time. We can't really make our own time machine. Not the kind that shoots you back in time. But we can't really make our own clock, right? So Unity has its own clock within it, and we're using it to tie it to our time variable. Also, to clear up any confusion about the fixed unscaled time bit, Unity has time, right? But time has many little like sub parts and stuff like that. You have time dot delta time, which is the little intervals between which it does time. It's got a whole bunch of stuff. But basically, fixed unscaled time is the time from the beginning of the game, which is what we want, right? Because when time starts in real life, it doesn't really stop. It just keeps going, right? And it's 1 second, then 2 seconds, then 3 seconds. That's what we really want. So it's a fixed, unscaled time that we want. And this should, in theory, work out. So let's head over to the game engine itself, Unity. So now we're within Unity and our script has been transferred over to the game engine itself. So let's check for any errors. Always check for errors. And they usually show up here, and we can see that there indeed is an error. And it says that cannot implicitly convert type unity engine.vector3 to float. Double click on it and it shoots us to our Visual Studios, which I shall show. Don't mind that. Right? And oh, I see where we went wrong rather. You see here acceleration, initial speed, and initial position. Well, we have these stored as vector 3s. Vector 3, as I explained, has 3 different numbers tied to it: x, y, and z. The thing is, we're trying to turn vectors into floats. That's not really possible. So what we want to do is we want to access the y component of these vectors, and remember, each of the vectors, each of their components, they're stored as floats. So what we want to do is we want to access the y component of these vectors, because we're putting in y values, and now everything should work out in theory. Always test, but this should work out because now we no longer have vectors magically turning into floats. That doesn't work in the coding world, by the way. No, now we have floats, 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 and it's all floats. Then we turn that into a vector by creating a new instance of a vector and stuff like that. So we go back to our game engine, and I'll show you guys that. And bada bing bada boom, we have no errors. This is amazing. So now we're good to just plop this boy onto cube here, and we have WMP, our script. Now let's move our little cube friend here up to y level of, oh, I don't know, 15. That seems about right. I'm also going to make a new object called plane. I'm also going to make a new object called plane. And I'm going to set its position to 0, 0, 0. There we go. And now this way we have a ground underneath our cube, so we know where it's going. Right. See, we have a nice ground. Let's color the ground. Why not? Because I like to color things, and it makes everything easier on the eyes rather than staring at a whole bunch of white, right? So let's color the cube, not the ground. That way we can have we can have some good contrast. Make a new material, call it cube underscore mat, standing for cube material. Set the color to red, and just put it onto the cube. If you don't understand what I'm doing in Unity, I suggest that you go check out some nice tutorials of Unity because I can't really explain that. All I can explain is me creating the physics engine, not really how Unity works. That's not the purpose of my videos. But here we have Cube Boy, and we'll call him Cube Boy, right? We have Cube Boy, and here is our script right here. You guys can see this, right? Yep. Here's your script, and as you can see, as I was saying before, we have the X value, the Y value, and the Z value, because it's a vector and it's made up of different values. We're going to only affect the Y because we're only calling on the Y, but later on we'll get into the X, Y, and Z all at once. But that's for another time. For now, let's set the acceleration to something like negative 9.8, which, by the way, is the acceleration on Earth. It's the reason why you're stuck to the ground and not floating. We'll set the initial speed to 0 for now, and initial position is going to be by default set by the transform. And now we can try and run this program and see if this works. In 3, 2, 1, and just like that, it works. Now, that might have been a bit too sudden for you. I know it was for me. So, what I'm gonna do is I'm gonna bring the game view over here. No, I want it here. There we go. Gonna scale it up here. And I'm going to move the main camera until I can see good old Cube Boy. Right here. And now we're going to move back to Cube Boy, press Control P, and watch it unfold. Oh, that was still rather fast. That's probably because I have my acceleration set to negative 9.8, which is, by the way, quite high Unity-wise, at least at this scale. So let's just set it to negative 1. Have a nice cube floating down. There we go. You can see that slowly descending, and it's going to pass through the floor, mainly because I need to have the rigid body component on it, but that's something that's going to involve physics, and it's the Unity physics engine, right? So I don't want it to interrupt with my physics engine, because obviously my physics engine is way more superior. Anyways, now we can have some fun and mess around with different variables, right? So our initial position, we'll just set it to 20 for now. Like, we're not going to change it because this is a nice height to view it from. But if I take my main camera and move it back, never mind, Control Z. I said move it back a little. There we go. Now we can have Cube Boy, and we can set its Y, rather its initial speed in the Y direction to, I don't know, 5 meters per second. And we can have some fun. You see how at first the cube is shot up and then it slowly comes back down once everything evens out, right? So we can set it to a little smaller amount so that it looks better. And you can see that it's shot up and then comes back down as if you threw a ball on the moon or something like that. Yeah, that's a pretty good concept. And that's our physics engine, or at least the first part of it, done. We were able to successfully create motion in 1 dimension and we'll talk about different dimensions later on, namely 2 and 3 dimensions, but you're able to successfully make motion in one dimension. I can also show you reverse gravity because that's fun. I can have the speed set to -5, right? You see what I'm doing here? And I can have the acceleration set to +2, and it's going to be as if you're living in reverse gravity. You know those scary dreams you have where gravity all of a sudden flips and all you can do is shoot through the sky all the way. You're trying to hang on to like your ceiling or like the little trees that are on your roof, but no, you're slowly being dragged away. Anyways, this is positive acceleration or reverse gravity. Look at that. So nice. So basically, that's our physics engine done. Here's the code for it, where we did all of this. But wait a moment, this can't be the end, right? And you're right, it's not. Because you see, from a physics point of view, yeah, it is the end. We figured out motion in one dimension, but at the same time, I'm supposed to be learning how to code. And as a coder or a programmer or whatever you want to call yourself, programmers don't like having the innards of the code just bare and exposed like we have it here, right? So what we do is something called decoupling. Decoupling is when you completely remove something like this from the actual script. You put it into another public class or whatever it is, and that way you can call on it whenever you want from wherever you are. And it makes it so much easier because this way you don't have to copy paste this get position, float time, float y value, blah, 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 all you don't want to copy paste that into your code each time you make a new piece of code. No, that's such a pain. It's nobody would like that. So what you do is you go back to Unity, you make a new C# script, and we call this the game actually not game object, let's call it cube boy. And now that we have the cube boy script, we're going to open it up, double click. We have the blank page, and what we're going to do is we're going to take these vectors, Control C, put them in here, and I'll explain in a bit what I'm doing and why I'm doing it. Control C this thing as well, which requires these vectors to be in place, otherwise it makes no sense. And what we're going to do is we're basically going to just Control C this, Control V this, and delete all of this and the mono behavior. Basically what I've done, alright, is by deleting the mono behavior, as you can see, by deleting the mono behavior, I have removed this piece of script. I've just more or less removed it from Unity. Like, I can't do anything with this in Unity, and all it is just a script that runs in the background, which is what you want a physics engine to be, right? When a game developer comes to me, asks me for my physics engine, right? They don't have to worry about whether or not I have my code right. They just have it running in the background and they can call on the functions within it. This concept of having one thing separate from another in coding or programming is called decoupling. And it just makes things cleaner, and it's what's done by professionals. So now we have a function, getPosition, within a public class WMP. So what we do is we go to the player's script, because cube boy in this case is just the player, and we call on an instance of WMP. So WMP, and let's call it fizz, is equal to new WMP, and just I have a reference script here to help me out every once in a while, and yeah, WMP, and then open close bracket there. So using this, what I've done is I've basically hey, there we go. Let's actually call this something different. Why not? Let's call it fizz with a capital thing. Basically what I've done is I have created an instance of this physics engine within the player's code, in this case Cube Boy's code. So what I can do is I can set fizz dot init. What in the world? No idea what that is, but fizz.init shall underscore speed is equal to initial speed. There we go. Fizz.initial pause equals to initial pause, and fizz dot accel is equal to accel. And what I've basically done is, once again looking at my reference, yeah, what I've basically done is I've called an instance of this physics engine within the player code, and then I've set these values to these values right here. Right? And because of this, because otherwise I wouldn't have any values for these. Think about it. If you go here, it has these public vector 3s and stuff like that, and it works out fine. But the thing is, I don't have the mono behavior here anymore, and it's the mono behavior that allowed me to see it in Unity and give it values to work off of, right? So by removing the mono behavior, I've basically made these empty variables. So what I'm doing here is saying that, hey, I have variables in here, they're called initial speed, initial position, etc. But I don't have any values for them. So what I'm going to do is I'm going to call on an instance of them, and I'm going to set them to these values, which I've also set within here, which I can actually call, or rather set within it, the game engine, because I have mono behavior here. And by doing this, I don't need to have all of this code exposed, and I have successfully decoupled the code. That's what programmers call it. I have decoupled it. So now what I can do is I can go back to my game engine right here, and oh, I have an error. As usual, always check for errors. So we go to our code again, and let's show you guys that. Look for the error. Where could I have made an error? Ah, I see. Right, so you see this get position thing? As far as the code is concerned, it doesn't know what I'm talking about, because get position only exists under WMP, right? So what you have to do is you have to use the name that you assigned for that instance of it, because I created an instance of WMP and I called it fizz, and that's the name. So you have to always use this name, fizz, and then dot. Then you can write a function, and now this should in theory work. So we save it, we go back to Unity. It assembles it, and there are more errors. But this time I know why the errors are being thrown up. You see, if you go to Cube Boy right here, project Cube Boy, the script that we have, WMP, is now no longer valid because remember we removed mono behavior, and it needs mono behavior in order to be a part of Unity. So what we do is we drag our Cube Boy script, which is the mono behavior one, and we place it in the place where WMP used to be. Plop it in there, and now, well, the errors should have gone away, but like it hasn't updated, but it will go away because you see when I press Control P just to test this if everything works, it reads the assemble and it does the cool reverse gravity thing. And so I can say that I have successfully decoupled my code by, if I go back here, by making one script for the actual player or the game object, and one script which is my actual physics engine. And this is like the only time that we're ever going to do explain how decoupling works. After this, it's just going to be me typing stuff in here and then moving here, and I'm going to just put in whatever new it is that I'm doing. When we do forces, I'll say we're adding a force. When we do vector, like 2D, 3D vectors, we're going to do that. So that's something that you can look forward to. And yeah, that's it for this video. Um, in the next video, I think I'll try and make a game using my physics engine. That's going to be kind of interesting, trying to make a game which only allows for movement in one direction, but I'll see what I can do. And you can look forward to that. And if you haven't checked out the first video I made and you're severely confused and you've somehow still reached the end of this video, um, uh, please go check that out because that's something that's very important. You need to know that in order to understand what in the world I just did here. So yeah.